Good morning students. In this video, I will be discussing on IPv4 classes, that is Internet Protocol version 4 Classfull classes. So we have totally 5 different types of classes, as I mentioned here: Class A, Class B, Class C, Class D and Class E. So in my previous video, I discussed on what is an IP address. There we have seen the address space for IPv4 is 32 bits and for IPv6 is 128 bits. So among these 32 bits, the IP address will give you the identification of two addresses. One is host ID, the other one is network ID. If I say this is 32 bits of IP address, normally we are representing in terms of 4 blocks, that is block 1, block 2, block 3 and block 4. This is 1, 2, 3, 4. Each block will be of 8 bits. This is 8 bits, 8 bits, 8 bits and 8 bits. Here you can see that's what I have represented the whole classes in terms of blocks. Each block will be of 8 bits. So the more information regarding this IP address you can watch in my previous videos. So out of these 32 bits, so based upon the class, few bits are allocated to network ID and few bits are allocated to host ID. So normally the host IDs we are using in order to generate the IP addresses or to connect to the systems. Network ID is normally used for naming the name of the network. So keeping that in mind, so how many bits are allocated to network ID and how many bits are allocated to host ID, the various classes have been addressed. So this is what class A. In the class A, out of these 32 bits, the first byte, that is first 8 bits are reserved for network ID. Okay, remaining 3 blocks, that is 24 bits are reserved to host ID. So it means that how many bits, how many systems we can connect, it is 2 power n systems. In class A I am talking, this n is nothing but number of host IDs. So how many host IDs we have? 24 bits. So 2 power 24 systems we can connect using class A. So that's what here you can see in class A. The yellow color is nothing but network ID, which is 8 bits. The remaining 3 blocks is nothing but host IDs, that is 8, 8, 8, 24 bits. So this is what class A representation. Similarly in class, and in that the first bit in class A is, we should be always 0. Means here this network ID what we have, in that it is 8 bits are there. No, the first bit is reserved for identification bits, that is 0, which I have mentioned here. So that is the identification of class A. Similarly, if you take class B, out of 32 bits, the 2 blocks, that is 16 bits are reserved for network ID, remaining 16 bits are reserved for host ID. Means you can connect up to 2 power 16 systems as IP addresses. So among these 16 bits, means first block if I take 8 bits, okay, the identification bit for class B is 10, means the first 2 bits should be 1 and the second bit should be 0 among 8 bits. So here 10. So this is the identification bit for class B. Similarly, if you take class C, so out of 32 bits, the 3 blocks, that is 8, 8, 8, 24 bits are reserved for network ID and only 8 bits are reserved for host ID. Means you can connect up to 2 power 8 systems, means 256 systems you can connect. So if you are starting any small company startup, then you can buy class C, where the service provider will provide you with 2 power 8 systems, means 256 systems you can connect. So in that the first byte, the first 3 bits should be 110, that is the identification bit for class C. Similarly for class D, in that there is no host IDs, all 24 bits are reserved for network ID as I mentioned here. And in class E, it is also all 20, it is in research actually. We will in real time we are using only A to D. Class C is meant for research. For class D, the first 4 bits should be 1110 as the identification bits, and for class C it is 1111. Okay. So in the exam, for example, if we give any IP address like 192.168.3.2, okay, and if they tell to identify to which class this IP address belongs, then as I told you, you should take only the first byte for the identification in binary. You should take 192 only first byte, and then you convert that into binary using 8 bits, and you should check the first bits. If it is 0, it is class A. If it is 10, it is class B, 110 it is class A, and 1110 it is class D, and 1111 it is class E. Instead of 192, if I take this address like 1.1.1.1, to which class? So first byte I will take 1. I should represent this one in 8 bits, that is 0, 0, 0, 0, 0, 0, 0, 1. So in that first bit is 0. So when it is 0, it is class E. So you can tell that particular IP address belongs to class A. In that way, whichever the IP address is given, you should take the first block, that is first byte, convert that into binary number, and you see the starting bits, and then you can identify to which class that IP address belongs. But here the big problem is to convert the hexadecimal number into binary number. So in order to avoid that, the other way you can identify to which class that IP address belongs is through a range. So here I have mentioned the ranges. So in class A, the range will be from 0 to 127. The IP address range means the first block. The first block should always start with either 0 to 127 for class A. For class B, it is 128 to 191. For class C, it is 192 to 223. And for class D, it is 224 to 239. And for class E, it is 240 to 255. So you need not to bother about the remaining blocks. Only first block is meant for identification. So if I come here, say 1.1.1.1, so 1, so the range is from 0 to 127. So you can say blindly that belongs to class E. Similarly, if this IP address you take 192.168.3.2, you should take the first block, that is 192. So 192 range is class C. So it is class C IP address. If I give like 129.3.2.1, so to which class this IP address belongs? 129 you need to check. It belongs to class B because the range is from 128 to 191. That is class C. Sorry, class B. So in that way, you can identify the IP address based upon the range. So you need to just remember the ranges of each and every class. Hope you understood. So sometimes they will give another way in the exam. Just I will show you once again. What they will give you, they will give something like the IP address like this, like 111 dot, okay, 2 dot 3.1. So to which class this IP address belongs, and also they will tell you to identify which are the network IDs as well as which are the host IDs. So as I already told you, 111.2.3.1. So first you should see the first block 111. So the range is from 0 to 127. So it is class A. So in class A already you know 8 bits first byte, that is 8 bits first block is reserved for network ID, remaining all 3 blocks is reserved for host ID. So you can just write 111 is the network ID and 2.3.1 is the host ID. So in this way you can just identify which is the network IDs and which is the host IDs. I will take one more example like 192.3.4.1. So to which class this IP address belongs, and also to identify which are the network IDs and which are the host IDs. So here you can see 192. So it belongs to class C. So the range. So this IP address belongs to class C, and in class C already we know the first 3 blocks is reserved for network ID. So 192.3.4 is the network ID, and the last block, that is 1, is the host ID. So in this way you can identify to which class the IP address belongs and which are the host IDs and which are the network IDs. So the second very important is subnet mask. So in classful IP addresses we have standard subnet masks. So this is the dotted decimal notation and this is the CIDR notation. I will tell both of this. So what I have done here, I have just represented the entire classes into binary numbers. So this ones you can see, this is nothing but network ID and zeros is nothing but host IDs. Already I told in class A, the first byte, that is 8 bits, is nothing but network ID, so I represent all ones. Remaining 24 bits are reserved for host ID, so I represented zeros. Similarly in class B, the first 16 bits are reserved for network ID and remaining 16 bits is reserved for host ID. In class C, the first 3 bytes, that is 24 bits, are reserved for network ID and 8 bits are reserved for host ID. So the network ID should be represented with ones and host IDs are represented with zeros. So if I want to represent this in subnet mask, okay, I can represent all ones is nothing but 255. Yes or no? If you convert that into decimal number, it is 255 and remaining 3 zeros, 0 dot 0 dot 0. So this is known as subnet mask for class A. Okay, so this will represent the network ID and this will represent the host ID. And the same thing can also be represented in slash n notation. So what we can do, slash, here n is nothing but the number of network ID bits. So how many bits we have for network ID? 8 bits. So we can write it as 8. So this is known as slash n notation. So this is known as subnet mask. Okay, and this is known as slash n notation, where n is nothing but a number of bits reserved for network ID. Similarly, if you take class B, so how you can represent for this class B? It is nothing but first byte, that is 255, all ones, dot, again this one, this is 255, okay, dot, and this one, all zeros are there. So 0 dot, this one 0. So this is nothing but subnet mask for class B. And what is the slash n notation? The number of bits for network ID, it is 16. So slash 16 is nothing but slash n notation. Just by seeing slash n, you can say that block belongs to which class of IP address. Similarly for class C, this is nothing but 255 dot, this is nothing but again 255, the second block, again dot, this is nothing but again 255, here I have mentioned it, and a dot 0. This is nothing but subnet mask of class C. And what is slash n notation? All bits, network bits, is nothing but 24. This is known as class C mask. And similarly, if you take class D, it is all ones. I told no, there is no host IDs, all are network IDs. Then it will be 11111111 dot. Like that, all ones will be there. You can represent as mask as 255 dot 255 dot 255 dot 255. So normally this class D is used for broadcasting. Okay, there is no unique casting in class D. Okay, and some example is there. So here I mentioned, just by seeing this address, find the class of each address. To which class this IP address belongs? They are given in binary. So I told now you can see the first bit. If it is 0, it is class A. Okay. Similarly for second address, you can see 1. The first bit is 1. If the first bit is 1, don't say it is class B immediately, because if the first bit is 1, here you can see, you should not say it is class B, because you should see the next bit also. If it is 0 only, it is class B, because otherwise if it is 1, you don't say it is class C immediately, because all bits are 1 only here, first bit. You should see the second bit. If it is 0, you should say class B. If it is 1, again it is not class C, because it may even have 1 in the class D also. Then you should see the next bit, like that. It depends. Okay. So similarly here also, since it is 1, I can't say it is class C immediately, because next bit also I should check it is 1. Then also I can't say it is class B, because next bit I should say, if it is 110 only, it is class C. If it is 111, again I should check which is the next bit. Like that, you need to check all possibilities and you need to identify. So it is 110, it is class C, I think. Okay. And here you can see it is in decimal form, 14.23.120.8. So the range is from 0 to 127. So you can say it is class C. And it is 252. The range is from 192 to 223. Sorry, class C, 224 to 229. So it is in the range of class C. So it is not even class C. You can see the ranges. In class C we have 0 to 127. In class B we have 128 to 191. In class C we have 192 to 223. So it is still bigger number, 252 is there. So class D 224 to 239, not even class D. In class C you can see 240 to 255. So it is in class E range because 252. So this IP address belongs to class E. So in that way you can identify to which class the IP address belongs just by seeing the first byte. So this is what about classful addresses. Hope so you enjoyed the video. In the upcoming videos I will explain about what is subnetting and how to find the first address, last address, middle address when they have given the single block of address in the organization. So in that way we can see even IPv6, all those things. So subscribe my YouTube channel for more videos. Thank you.